Out there beyond our solar system, orbiting distant exoplanets, are worlds we have barely begun to understand. Worlds that could hold clues to the birth and evolution of moons orbiting distant planets. And perhaps reveal echoes of our own solar system's past. Imagine rocky worlds in deep shadow, oceans hidden beneath ice, or volcanic landscapes reshaped by intense gravity. Each exomoon is a question, an echo, a possibility of life as we've never imagined. Today, we dive into the physics that makes these worlds possible. Why do they exist? How do they form? Most importantly, what do they teach us about the universe we call home? Humans have long been fascinated with life outside of Earth, within the stars, right? We grow up watching shows like Star Trek, Star Wars, and we think to ourselves, in the vastness of space, there has to be something. And if not, then at least have more like our planet. There has to be friendly atmospheres out there, at the very least. Well, NASA's JPL have taken steps to address this idea. The exoplanet WASP-49b is orbiting a star about 600 light years away. Now, they think that this exoplanet may have a moon, and that moon may be violently volcanic. Exomoons likely form in two ways: from the same swirling disk of gas and dust as their planet, or as objects captured by the planet's gravity. Gas giants in particular create conditions where thick disks of debris enable moons to take shape. From icy bodies to volcanic surfaces, detecting something so distant and small is challenging, but astronomers rely on indirect methods like tracking tiny changes in a planet's orbit. Transit timing variation, or TTV method, measures how a moon's gravity influences a planet, hints at its size and mass. The exoplanet WASP-49b is orbiting a star about 600 light years away. This exoplanet may have a moon, and that moon may be violently volcanic. Now, why is that so important? Why is the moon with violent volcanoes address the possibility of life in space? Now, Jupiter has a moon named Io, which is violently volcanic. As it orbits closer and further away from Jupiter, Jupiter's gravitational force squeezes and releases the moon. That squeezing and releasing creates intense heat inside that moon. And so Io is releasing the heat in the form of volcanoes. JPL thinks that the same situation may be happening near exoplanet WASP-49b. May have a moon that's orbiting the planet. And again, as it nears and gets further away from WASP-49b, It's being squeezed and released, generating heat and creating multiple volcanoes. Observing exomoons lets us draw comparisons with moons in our own solar system, like Europa and Titan. Some exomoons could even be located in the habitable zone, where conditions might support water and possibly life. If we could find other moons with volcanoes, maybe there's a moon where heat's being created due to its exoplanet, but may not be as violent. Maybe the heat is just enough to liquefy water. And if the water is liquefied and it doesn't melt human beings, it may be able to support plant life. That's what's very exciting about this research. How do we know that volcanoes may exist on this moon? Well, as JPL has been monitoring WASP 49b, it's noticed a cloud of sulfur around the planet. The cloud isn't following the planet's orbit. The planet is orbiting its star at regular intervals, but the cloud isn't doing the same. It has a mind of its own. And this leads scientists at JPL to believe that it may be caused to the volcanoes on the planet's moon. Though it's not confirmed, it's very promising. And the more moons we find outside of our solar system, maybe there's an extreme difference in temperature, and eventually find one that's suitable for life. That's very promising, very exciting. Now, we've never discovered an exomoon. It's very difficult to detect. They're very small and very far away. Cutting through all the noise of a massive gas giant planet, it becomes very difficult. We're having to upgrade our technology, think outside the box in terms of methods to detect exomoons, because we find that the research for finding exomoons may be very beneficial to the future as humans begin to travel into space. These moons represent one of the most exciting frontiers in modern astronomy, revealing complexities in planetary systems that continue to surprise us. Each discovery hints at new possibilities and invites us to imagine environments unlike any we know. These moons call us to explore and ask questions that reach to the edges of our understanding. Thank you for joining me on this journey. Now, if the mysteries of space, math, and science captivate you, make sure you subscribe for more explorations. Until next time, keep looking up.